There we go. Does this not work? I can't. This is bad. This is not good so far. Very bad. Okay, let's see if it works. 2-4b. We're going to do synthetic division. Now, synthetic division works sometimes, but not all the time. It only works with linear divisors. So, but that's all we're going to do because that's all it works with. So we're going to first talk about a theorem here. Okay. All right, so we're going to do the rational zero theorem first. So the whole purpose to long division, synthetic division, is so that we can find all of the zeros of the polynomial. So if we divide and it comes out to a remainder of 0, then we know that it is a 0. Now the rational zero theorem, it doesn't tell you what the zeros is, but it gives you a list of possible zeros. It narrows it down, okay? Because there's an infinite amount of numbers that a polynomial can have as zeros, but this narrows it down to maybe 48 of them, or 24, or 3, or whatever, 2. Okay, so it narrows it down, doesn't give you the exact amount. And here's how you find it. The list of possible zeros are going to be P divided by Q. P divided by Q, where P is the factors of the constant. Factors of the constant. And Q are the factors of the leading coefficient. Okay? So, the ones at the end divided by the ones at the beginning. Factors. So factors, like if you talked about the number 6. 6 has factors of positive 1, negative 1, positive 2, negative 2, positive 3, negative 3, positive 6, negative 6. Okay, those are factors, numbers that go evenly into 6. So let's go ahead and let's do one. Example number 1. Let's say that we have this polynomial function, f of x equals 2x to the third minus 3x squared minus 5x minus 12. And we're going to list all the possible zeros of this polynomial. There's a lot, okay? So we're going to take all of the factors of negative 12 and divide it by all the factors of positive 2. So the factors of negative 12 will be plus or minus 1. So numbers that go into 12, plus or minus 2. What else goes into 12? How about 3, 4, 6, and 12. And we're going to divide that by the factors of the leading coefficient. And the numbers that go into 2 would be plus or minus 1, plus or minus 2. Now, I do not need you to split all of these up and write them all out. This is a fine answer for me, okay? Because I could ask you something like, is 4/3 a possible zero? Okay, is 4/3 a possible zero? You would look at your list and you'd go 4 divided by 3, no, it's not a possible zero, okay? 1/1 is 1/2, 2/1, 2/2, 3/1, 3/2. All of those are, but 4/3 in this case is not. The factors of the leading coefficient. So it's always like the top is the bottom, or the last ones, and the bottom is the front ones. Okay, so if they ask you to list them all and then they say to find them, you are able to graph it on your calculator, okay? Don't start testing all of them. That's what they did, 100 years ago or something. But we have calculators where you can go to your calculator and you can plug in 2x to the third minus 3x squared. Ooh, you're getting your calculator out. Cute. 3x squared minus 5x minus 12. Okay. Zoom 6.
Look at that crap.
Can you do that one more time?
Yeah.
She just laughs.
Oh, okay.
Yeah, I put the polynomial in, You might need to change the window though. Just to kind of, because 12 could be a possible 0. We can see that from our list, 12 over 1. I know this is a cubic function. It just goes through at one time, okay? And can you see what that one time is? Can you take a guess? 3? X equals 3. Now, here's how you can tell if 3 is a 0 of this. We can go ahead and figure out what f of 3 is. Okay? So you can take 3 and you can plug it in. You could go to your graph right here, since you have it graphed. Hit trace and plug in x equals 3, and look what y is. It's 0. Okay? Or you can, if you didn't have your calculator and I asked you, you could plug 3 in, and f of 3 will equal 0. And that's the only rational 0 that worked out of this whole list of them. But it is in the list. It's right here, 3 over 1. Okay, let's go ahead and now let's do some synthetic division. Okay, so part B. So long division is nobody's favorite, I'm assuming. Nah, it just takes a long time. It's not that fun. So let's go ahead and we are going to divide 2x cubed. We're going to take that polynomial that we just did, minus 3x squared minus 5x minus 12. We're going to divide that by x minus 3, which we know that 3 is a 0. We should get a remainder of 0 when we do this because it is a factor. So here's how you do long division. You're going to take 3 instead of negative 3. You take the opposite. You turn your long division sign upside down. Do you remember this? You take all the coefficients and you write them here. 2, negative 3, negative 5, negative 12. Synthetic division is like always opposite of what you're used to. So we take positive 3, write it upside down, and when we go like this, we bring the 2 down. You're going to multiply. 2 times 3 is 6, and then what do you do with your columns? You add them. Okay? Long division, you subtract. Synthetic division, you add as you're going down. So then I get 3. 3 times 3 is 9. And then I add my column. Negative 5 plus 9 is 4. And I do 4 times 3 is 12. And my remainder is 0. Yay. So this right here will always be your remainder. Okay? And then next to it will be the constant term, linear, quadratic. Okay? It just goes up from there. Could be cubic, quartic, all the way up. So then your answer would be 2x squared plus 3x plus 4. And that's it. You're just dividing using synthetic division. Now, after we take the quiz and we do 2, 5, and A and B, we're going to find out that there are 3 zeros, and there's going to be 2 imaginary because only one of them showed up, and we're going to have to do quadratic formula to find the rest of them. And blah, blah, blah. But not right now. Today we're just doing synthetic division. You're fine. Okay, so let's do another one. Oh, I didn't even label that one. I'm sorry. That was number 2, huh? Number 2. It doesn't? Oh, I like my notes to be all, good. All right, you try this. All right, so you're going to take x to the 4th minus 3x squared plus x minus 1. And we're going to divide that by x plus 2. Okay. Now, do you notice something about the polynomial on the left? It's missing cube. You have to fill it in with a 0. Okay? So we're going to put negative 2 on the outside. And then we're going to put all our coefficients. So we have 1x to the 4th, 0x cubed, negative 3x squared, 1, and negative 1. We're ready to go. You want to try it? Yeah, you try it.
Oh, me?
Yeah, you. You got a remainder of 1?
I did it.
Yay. Okay, so make sure that you write it as your answer, though. 6 is going to be x cubed minus 2x squared plus x minus 1. Your remainder you should write as 1 over x plus 2. Sometimes the book will say as long as x is not negative 2. We don't need to write all that. We did domain so much that we're good. Okay, now the other thing that's interesting is if you were to take negative 2 and plug it into this polynomial, your answer would be 1. And where I get that 1 is from the remainder. It's called the remainder theorem. If I asked you to do f of 3 and you did synthetic division with 3, it would be whatever the remainder is. It's kind of cool. All right, last one, number 4. No one seems impressed by that today. Costco?
Dude, that guy's face is crazy.
Wow. Okay. That was Ryan.
I'm Bill. That's the guy's name.
All right, 2x to the 4th minus 7x cubed minus 8x squared plus 14x plus 8. Okay, so here's a polynomial. Yep, it's a lengthy one. We know that this polynomial has 4 zeros, okay? Suppose that we are given 2 of them. We are given that 4 and negative 1/2 are zeros. Our job is to find the other 2, okay, without a calculator. Can't just graph it. They're actually really ugly. Find the other 2 zeros. Okay, so we're given 4 and negative 1/2 and this huge polynomial, this quartic, this x to the 4th. We need to find the missing 2. So what we're going to do is we're going to divide it. We're going to divide these factors out until we get it down. It's almost like a factor tree almost when you were a kid and you had to make those. Okay, yep. So we're going to take 4. We're going to do synthetic division with it. Now we're told it's a 0, so what should my remainder be? 0. If it's not, then you did something wrong. They're not going to lie to you. The book? Yeah, not this time. Yeah. All right, so we're hopefully going to get 0. If we don't, we better figure out what we did and do it over again. And so we bring down the 2. 2 times 4 is 8. We're adding our column here, and we get 1. 1 times 4 is 4. Negative 4. Did I do it wrong?
Yep. No, you're good. You did it wrong.
Okay. And then I have negative 16, negative 2, negative 8, 0. Whew. I got scared there for a minute. All right, then we're going to do it again. And we're going to use negative 1/2 now. Don't worry, I know it's a fraction. You'll be all right. Negative 1/2. We'll do the whole thing. Bring down the 2. 2 times negative 1/2 is negative 1. You add and get 0. 0 times negative 1/2 is 0. You add negative 4 to 0 and get negative 4. Half of negative 1/2 times negative 4 is positive 2, and your remainder is 0 again. Yay! Okay, so you kind of just showed to prove that both of those were zeros, and what you end up with is 2x squared minus 4, which is a quadratic. And you know how to solve all quadratics. And so it's really up to you, however you want to solve this. Because it's missing an x term, I would just solve by extracting roots, which means you're going to add 4, divide by 2. So x squared equals 2, which means x would equal plus or minus rad 2. Those are not rational zeros. They are zeros. They're not rational. And then the other ones are 4 and negative 1/2. So those are your 4 zeros of your polynomial. Okay? So that's what synthetic division does. It helps you to get all the zeros when you have a couple, helps you get all the rest of them.